Hi there, folks. Root Beer here with question number 5, the very halfway point of our Euclid 2009 contest. In the diagram, triangle ABC is isosceles with AC equals BC equals to 7. Point D is on AB with CDA equal to 60 degrees, AD equal to 8, and CD equal to 3. This is actually kind of nice. There are a few triangles that have integer side lengths with special angles like 60. There are some with 45s, 120s. They pop up very rarely on contests. They're not nearly as common as the Pythagorean Triples, which are triangles with integer sides that have a 90 degree, but 60 degree is still pretty cool. 378 is a good one. I think 357, it's not going to be 60 degrees, but I think it's 120 degrees or something like that. I don't know. Just little things you slowly pick up. But, okay, we want to determine the length of BD here. Okay, so what can we do? Well, we don't have a length for our triangle, certainly. But we'll draw a picture a little bit. So 8, 3, 7, 7, and BD here. So we got a nice little 60-degree triangle here. So that means that this is going to be 120 degrees. Oh, is this a 357 triangle? Is that the one? It does have 120 degrees? Oh well. Suppose I didn't know that, and actually I'm not entirely confident in that, but I think my guess right now is that this is 5, and I've stumbled upon it just by remembering some nice numbers, but we'll see, we'll see. What would I do if it wasn't nice numbers? Okay, I got this 120 here. And then by the cosine law. How do you know to use the cosine law? Well, the cosine law and sine law, I mean, this is what trigonometry is really all about as a practical application. Trigonometry is pretty nice, and it has its uses in lots of places. You use it a lot in calculus and polar coordinates and things like that. But sort of the most immediate application and at a high school level for trigonometry is completing the information about triangles. I have two sides and an angle. I can usually use cosine law or sine law to get some of the other information. Other angles, other sides. Well, I know the cosine law says if I've got triangle ABC and the opposite sides are A, B, and C, then it turns out C squared is a squared plus b squared, which looks a lot like the Pythagorean theorem. We'll comment about that in just a moment, minus 2ab cos c. Now, incidentally, if this angle up here is 90, this whole term goes away, he's 0, and you do get the Pythagorean theorem. It's pretty nifty. But we don't have a 90, we have a 120. But we have cb squared is going to be equal to CD squared plus DB squared, the thing I don't know, minus 2 times 3 times, let's not plug that in right away, 2 times DC times DB cosine of 120 degrees. So you can grab your calculator if you need to. We get a 49 here, we get a 9 here, we get a thing I don't know, dB squared. We could replace it with x if we wanted to. Actually, let's do that because I think we're going to get a quadratic in a moment. So x squared minus 2 times 3, so let's say 6. X. And what's cos of 120? Again, grab your calculator if you need to, but it's going to be 1/2. Okay. So this is 9 plus x squared plus, or minus 3x. Minus 3x. Well, we'll bring the 49 over to the other side, and then we're going to get, did not go to the x page. There we go. So we'll bring the 49 to the other side, so we'll get x squared minus 3x. 9 minus 49 is minus 40, so all this has to be equal to 0. Quadratic formula, or try and factor it out. Two numbers that multiply to 40 that differ by 3 are 5 and 8. And so we'll have x plus 5, x minus 8. So it's got to be 8? No, that can't be right. I must have done something wrong. I feel like I'm off by a sign. Oh, cosine 120 isn't a half, it's negative a half. So this is a plus 3x. Alright, not too big a goof. So this is a plus. Still two numbers that multiply to 40 and have a difference of 3, but now it's going to be the bigger one gets the plus, the smaller one gets the minus because our b value here is positive. So x equals 5 or negative 8, except x is a length. So we can get rid of the negative 8. So dB is 5. And it was a 3, 5, 7 triangle. It's got 120 degrees in it. Kind of nifty that it worked out that way. And you can, there's, it's kind of interesting to explore these. I don't remember them off the top of my head. But if you've seen Pythagorean triples and like you've really explored them, you know there's actually kind of a very nice formula where if I give you an integer u, an integer v, and an integer k, that I can get a formula for Pythagorean triples. You know, it'll generate all Pythagorean triples. There is a way to get a similar formula that does all of these triples, like 3, 5, 7, that give you the 60 degrees or the 120 degrees. I just don't remember what they are off the top of my head. For those of you who are interested, I believe the Pythagorean triple formula is if I give you a k, a positive integer k, a u, and a v, then if I take b is 2kuv, a is ku squared minus v squared, and c is ku squared plus v squared, then this always gives you a Pythagorean triple. I believe so. I'll just quickly plug in something like, what if u was 2 and v was 1 and k was 1? Then I'd get 1 times 4 minus 1, 2 times 1 times 2 times 1, and I'd get 1 times 4 plus 1. This would be 3, 4, 5. So this is a nice formula, not for this question. I'm completely digressing right now, but it's a nice formula that gives you all Pythagorean triples in a pretty cool way. And as all I'm saying is there's a formula for these 3, 7, 8 triangles that have a 60 degree in there. I just don't remember what it is. All right, that was just A part. So what have we got? We got a B part to go. In the diagram, triangle ABC is right angled at C. Also, 2 sine B is 3 tan A. Determine the measure of angle A. So we want this angle here. We know things about that angle and this angle. And we got a nice little 90 degree here. Okay, let's copy things into our notebook. I think I'll just give myself a brand new piece of paper. So we got C here, B I'm pretty sure is here, A is here. We want angle at A, C, and B. Let's just make sure I have the numbers or the letters right. Yep. Okay, and then 2 sine B is 3 tan A. We'll just bounce back. Okay. All right, we're good to go. All the relevant information is copied. Now, because we got a nice little right angle triangle here, we might remember Sohcahtoa, which tells us, okay, if I have a particular angle, not the right angle, in a right angle triangle, the sine of that angle is the opposite side to that angle, so this one over here, divided by the hypotenuse. And similar rules, like adjacent and hypotenuse, opposite over adjacent. This gives us things like the tangent. So what does Sohcahtoa tell us? And we should mention it. I forgot this is the write-up question, so let's just very quickly start writing this up. We might say something like, by Sohcahtoa, we can see that tan of A is opposite, so little a, over adjacent, so little b. And sine B is going to be opposite, so little b, over hypotenuse C. Okay, so we are being told 2b over c is 3a over b. Okay, what can we do here? What indeed? suppose we could multiply and say something like 2b squared is 3ac. And now it's a Pythagorean triangle, so by Pythagoras, we could say something to the effect of, well, b squared is equal to c squared minus a squared. And I want the measure of angle A, right? Yeah, okay. So then I could say 2c squared minus 2a squared is equal to 3ac. And that really almost looks like it should have 2c squared minus 2a squared. I was going to say it almost looks like something like a sum of square, like an a plus c or an a plus 3c squared or something like that. Except that there's this pesky minus sign here. So, what to do? What to do? I suppose I could say something like 2a plus c, just using difference of squares, is 3ac. But this isn't especially helpful to me, I don't think. Additionally, I need angle A. How am I going to get angle A if I'm just messing around with these side lengths? What can I do? I've got to somehow argue it down to some sort of nice, neat, I guess maybe ratio or something like that. Like if I could recognize that something like b over c had to be, I don't know, what would be good? Root 3 over 2. And that's something, that's an angle that I know. So that would say, oh, sine of b has to be root 3 over 2. That tells me sine must be, that b must be 60 degrees, and therefore a is 30 degrees. So I guess I'm looking for ratios like that. Do I have enough information for something like that? That's the challenge here. I feel like I'm missing a piece of information. I just don't quite know what it would be. Can I? So I know this might go somewhere, but I don't think it will right now. I feel like I need something else. A over b. Is there a way to... The problem is the b's. I can't cancel out the b's, but I could say 2/3 is ac over b squared, which again is not the most helpful thing in the world for me. Also, 2/3 isn't the nicest number for me to be working with. So what could I do? I could shoot for something like an a over a c or a c over b. If I could just get a fraction somewhere, that would be helpful. Well, so... okay. Thought. If I'm in my triangle, I got A here. I have A, B, C. Okay, I know that A over B is the tan of A. And we're told B over C. Now that's the sine of B, but that's also the cos of A. There we go. So what we really have is 2 cosine of A is 3 tan of A. So, right? Yeah, because this is adjacent, this is hypotenuse. So 3BC, 2BC is 3 AB. And then what could I do from there? I suppose I could. So tan is 3 sine A over cos A. So I guess I could say something like 2 cos A, or cos squared A is 3 sine A. But cos squared, so incidentally I'm scratching this part out because I don't need it anymore, because I think I've almost got this. So I don't need any of this. There we go. So we would just jump straight from the b sine of b is b over c to saying, well, that's also cos of a. I think that's our key fact here. And then cos squared is 1 minus sine squared. And now I'm going to get a quadratic just in terms of sine of a. And that'll lead me to 2 possibilities. I'm going to suspect that one could be rejected, maybe. So I'll get 2 minus 2x squared is equal to 3x. So 0 is equal to 2x squared plus 3x minus 2. Off the top of my head, I'm having difficulty factoring. Well, could I do 2x and let's say plus 1. No, I can't do minus 2 there, but maybe I could do plus 2 minus 1. Right, 2x times x, that's 2x squared. 2 times, so this 2 times this 2 is 4. 1 minus 1 is 3. And then the minus 1 and the 2. Okay, so we got it. So, geez, that's a terrible lesson. I need to stop writing before the page flips. So sine of a, which is equal to x, is either, what have we got? It's either 2 or negative a half, was it? It's either negative 2 or 1/2. Negative 2 or 1/2. Of course, the negative 2 can be discounted. So sine a is 1/2. Why can it be discounted? Because sine is always between negative 1 and 1. So sine a is a half. So a is going to be the smaller of the two. So 30 degrees. Oh, cool. That's the one I predicted, right? Well, not predicted, but I used it in an example a little while ago, right? I remember I was yammering on, and then I said, was it this picture, or was it a picture over here? But I said something to the effect of, if I could just figure out some sort of ratio and get b, and say b was 60, and I just plucked that out of my head just as a number I recognized. Cool. I don't think my subconscious was just working faster than me. It was a random coincidence. But there we go. We've got 30 degrees. I've shown my work. I've said, okay, I would say the big key things there for the B part were set up things, get the ratios from Sohcahtoa, and then point out that sine B is actually just cos A. And then from there, we got my quadratic, solved my quadratic, got rid of the minus 2 possibility, and it falls right out from there that A is 30 degrees. Okay, so that does it for question number 5. We are officially done the contest. Well, sorry, not done the contest, done half of the contest, so yay. And I will see you guys in the next video for question number 6. Okay, till then, take care.